This is a Department of Energy funded project, and the project is looking at trying to balance energy consumption or try to reduce energy consumption versus trying to either maintain or increase occupant comfort levels. And so we're looking at trying to balance the two against each other in a system called BLEMS.
So the main problem in current buildings that are operated with centrally controlled HVAC systems is buildings are occupied to their 1/3 of their design occupancy, and there's quite a bit of energy wasted. Our testbed building is an office building with some classrooms, but mostly offices that are occupied by faculty, staff, and research students.
I have an office on the 3rd floor of Lewis Hall. I've always been someone who found the rooms usually too warm. When the BLEMS people came by and asked me to respond about how I felt, it was sort of, I was made for that because I was always complaining and would complain about that with little effect. And my nightmare was coming on the weekends when there was no air at all.
The building has an advanced energy management system with a bunch of sensors deployed at the building. In addition to the existing sensing infrastructure, we have installed sensor boxes in each room.
50 BLEMS boxes are installed in the testbed building, and each sensor box consists of Arduino microcontroller with support for Wi-Fi communications. All the components are low cost, high resolution, accurate, and non-intrusive. Each sensor box holds a number of sensors, including a light sensor, a sound sensor, a motion sensor, a CO2 sensor, a temperature sensor, a relative humidity sensor, a PIR sensor, and a door switch sensor. Data is automatically queried, timestamped, and stored in an SQL database.
So we came up with this framework that enables occupants to communicate their preferences.
And so I kept sending them responses about whether it was good or bad and so forth.
By getting the preferences and associating them with the environmental variables such as temperature and humidity, we learn occupants' preferences profiles over the time, and then we use a complementary controller on top of the existing HVAC system controller to improve the experience of occupants and save energy.
We measure the performance of the building in terms of comfort and energy, and we observe considerable improvement in user experience and energy savings for about 25%.
We have developed algorithms that actually detect occupancy as well as estimate and predict occupancy at the room level, and then take that to the zone level and controls the building based on occupancy information.
The performance of the 6 machine learning techniques was evaluated in both single occupancy and multi-occupancy offices. The demand response occupancy controls was then implemented. The simulation results demonstrated that a total of 20% of the gas and 18% of the electricity could be effectively saved if the occupancy model was integrated with the HVAC control systems compared to the conventional HVAC controls that are currently applied.
So the net effect was converting me from someone who was, was constantly, unhappy. And I don't know what they did. I don't pay any attention, and I don't seem to be unhappy about the temperature anymore.